Namaskar. So let's proceed in designing the microcontroller. Today we will see I2C interface, I2C interface with microcontroller. Okay. So what we have to do first is this is our microcontroller and the basic schematic that you already know that it has the power supply, ground, proper programming, like connector and reset. I have added reset switch as well. So now the microcontroller is quite sturdy, like the basic circuit is very much fine. Okay, our aim is to add one peripherals slowly. So we have studied UART last time. Now we will be studying I2C. So first of all, let us try to open data sheet of this microcontroller and see which pins are assigned for I2C and how we can approach for it, right? So let's open the data sheet. Once we open the data sheet, what we can do is we can directly see here we have the features, and in these features you see one I2C interface supports. Okay, so one I2C is there up to 1 megabit per second. So I2C is there. Next, if we see the table of contents, you can try to find out which pins is giving you that. So I had told you you can go to either pin attributes or signal description. So pin attributes, it will be very difficult. You have to look into the lines which are supporting the uh, I2C pins. Okay, so you can keep searching. So see, yes, it is there. You can see I2C 0, I2C I0, right? And the pin numbers that you have to see is in VSSOP 20 package. So VSSOP 20 package is here, right? I2C SDA is here also, pin number 4, and I2C SDA, this is not available, pin number 11, like that. So instead of doing this, you will be having ready in your Excel sheet or somewhere. However, the main criteria that you have to understand is go to your signal description. Okay, and they have categorized the pins based on the functionalities. Okay, so all the ADC pin are at one place similarly, or all BSL I2C pins are at one place, all these things. Okay, so let us find out I2C pins. So GPIO I2C pin, right? So this is the approach that we should be having. Okay, now just see the table, header. So header, we have to see 20 pin VSSOP on which we are working on. So in this I2C pin, this row, you can see clock lines are 5 and 11 and data line is 4. So data line is 4, that is available, and 5 and 11, that is available, right? So let's go here. 5 and 11 for clock line. So 5 is already used for reset signal, so I am not going to use this for uh, my clock line. Okay, so 11 is the only choice that we are having. Since this is very small microcontroller, you are having a limited number of pins. Okay, so put it this line as my I2C SCL line, that is clock line. Okay, and this will be a input that will be coming from, or no, this will be an output because it is going to give you the clock line to the EEPROM. Okay, now coming to the fact of pin number 4, which will be my SDA lines, right? So this will be I2C SDA line. You can keep this line as 0 ohm. Okay, or even 100 ohm. If you keep, that is not a problem. Okay, so you can keep it 0 ohm. Now you must pull it up by some resistor, like let's say I have put it here I2C SDA 4.7k and 4.7k. Based on what this particular resistor value is decided, if you increase this value to 4.7 or 10k or something like that, the speed of the I2C lines will be reducing. Like let's say it will be 100 kbps, okay, or 100 kilohertz or 400 kilohertz. If you want to make, then what will happen? You have to reduce it to let's say 3.3K, or even if you want to make it 1 megabit per second, then what will happen? You have to reduce it to, let's say, 2.2K. So as and when you increase the speed of the I2C lines, your value of resistance should decrease. Okay, that's the one thing. Now I have put it DNP, that is do not populate. This, there is a reason for that. Actually, in your microcontroller schematic, you always keep this pull-up resistor provision. Okay, so that you should not struggle later. So this is how, hope you have understood how I can, like interface my I2C lines, how I can identify the lines, and then how I am going to connect the I2C lines. One will be SDA lines, one will be SCL line, that is one is clock line, one is data line, and both the data line and clock line will be pulled up through a resistor, and the resistor value is designed, or is, like identified based on the speed that you are working on. And like while working with EEPROM, you can definitely always put 4.7K, but if you want to reduce the speed, you can still go ahead with 10K, and if you want to increase your speed, you have to reduce the resistance value. It depends basically on, like gate switching on speed. Okay, next we'll see how we can interface an EEPROM. So this I'll explain you based on the data sheet and finding the like a particular component for a particular EEPROM. So hope you have understood how you can assign a I2C pin to a microcontroller pin. And if you do have any questions in identification process, or any questions in pull up the particular data line, then you can put your comments on the comment box. Thank you so much. Bye.